Hello students, welcome back to the lecture series on retrosynthesis. Friends, today we are going to learn about retrosynthesis and synthesis of simple amines as well as some nitrogen containing heterocyclic compounds. So all the nitrogen containing heterocyclic compounds are very useful entity in organic chemistry. So let's study the first synthesis of amines. So amines can be prepared by reduction of oximes, nitriles or nitro compounds. So if we reduce the oximes, nitriles or nitro compounds, we get primary amines. For the secondary and tertiary amines, we need to reduce amides. So amides can be easily formed by the reaction of acyl chloride and amine. So these strategies we will apply for the retrosynthesis of amines. For primary amines, we will think about reduction of oximes, nitriles and nitro compounds. For the preparation of secondary and tertiary amines, we will think about the amide formation and then reduction of that amide. Okay, so these two strategy keep in mind for the retrosynthesis of amines. So let's begin with first example. Now this is your target molecule. So what we think about this target molecule, how we can retrosynthesize this target molecule. So as you can see that there is a CH2 NH2, that means it can be prepared by nitrile reduction or nitro reduction. So you are right, we have two possibilities. Either we can go for the FJ of this molecule to get CN over here, that is this is CH2 NH2 is converted to CH2CN. Okay, reduction of this nitrile, okay, benzyl nitrile can get us this molecule. So this type of benzyl nitrile can be easily prepared by reaction of sodium cyanide or potassium cyanide with the benzyl chloride or benzyl halides. Okay, and this benzyl halides can be prepared by simple formylation reaction. Okay, so this is how we can go for the synthesis of primary amines. Either this NH2 is converted to NO2, which will reduce to the NH2, but this can be achieved only if we have double bond over here. So this type of strategy we are applying for the synthesis of primary amine. Now let's see another example of secondary amine. Now this is secondary amine. So we cannot think about the FGI because we already have two different group attached to this nitrogen. So let's think about making this one amide. So we can easily prepare amide, and from that amide we can prepare this target molecule by reduction with LiH4. Now friends, you can see that this is our target molecule. We will go for the FGI, that is we are going to add a carbonyl group to the next carbon of this nitrogen. Okay, we are going to add carbonyl group over here. So that's why we are going to get the amide. And amide, you know that it can be easily prepared by reaction of amine and acyl chloride. Okay, so we have this disconnection over CO and NH bond. Okay, we will get acyl chloride and amide. Reaction of this, we will get amide, and this amide can be reduced in presence of LH to get the final compound. So this type of, again we have this amine. Okay, this is a primary amine. So friends, this primary amine can be prepared by reduction, and you can see that this is prepared by reduction of oximes. So oximes are prepared by reaction of carbonyl compound with hydroxylamine hydrochloride. So this is how we are going to get this NH2 over here. So how we can get this keto? Simple Friedel-Crafts acylation of benzene with this type of acid chloride compounds. So let's see the synthesis of same molecule. Synthesis is very simple. The first step is Friedel-Crafts acylation to get this kind of product, and then reaction of hydroxylamine hydrochloride, we will get oxime over here. Okay, this is a typing mistake in that book. So it should be NH2OH, hydroxylamine hydrochloride. Okay, hydroxylamine hydrochloride. So reaction of this hydroxylamine hydrochloride with this keto will get us oxime, and that oxime is reduced to amine with the help of LH. So we get this kind of amines. This amines is treated with the benzoyl chloride to get our amide. Okay, amide we will get by reaction of this amine with the benzoyl chloride, and then reduction with LH we will get our final compound, that is a target molecule 242. This is how we are going to prepare primary and secondary and tertiary amines. Okay, for primary amines we need to think about reduction, and for secondary and tertiary amines we are going to convert this amine into amide, and after that disconnection of amide for acyl chloride and amine. Okay, now let's go for the next molecule. Okay, we have again secondary amine, and this is symmetric, so on any one of carbon we are thinking about adding carbonyl group. So let's do that. So this is our target molecule. So FGI will convert this amine to amide, and this amide finally we are going to get by disconnection of this carbonyl and NH bond. So reaction of this amine with the acid chloride will get our amide part, and amide on the reduction will give us our target molecule. So this is the strategy for the synthesis of retrosynthesis of this molecule. So let's see how the synthesis looks like, because it's very interesting synthesis. First step is, that is a simple electrophilic substitution reaction. We get CH2Cl. It's a chloromethylation. After chloromethylation reaction with potassium cyanide, we will get CN, substitution of CN with this Cl, and then benzyl cyanide in the presence of HCl that is hydrolysis of this CN will lead us to COH. So this part is for the acyl chloride. So how we will get amine from this CN? Simply by reduction in presence of H2 nickel. So H2 nickel will help us to reduce the CN to CH2NH2. So from this part we will get CH2NH2, that is one part, and again same molecule after hydrolysis will get us COH, on which chlorination will get COCl. So reaction of this amine and acyl chloride we will get target molecule 246. So this is how we are going to prepare secondary amines with the help of amide formation and then the disconnection of amide. So let's go for the next molecule. So besides simple amines, let's see some heterocyclic compounds containing amide type or amine type functional group. So here we have N and then carbon near this N, that is amide functional group. So we need not to add another amide group, just need to disconnect this amide. So we have two amide type of linkage, so we will disconnect like this. Okay, we will disconnect like this. We will get aniline and this kind of, now you already studied. So this is a 1,5 dicarbonyl compound. Let's count 1, 2, 3, 4 and 5. So this is 1,5 dicarbonyl compound. When treated with aniline we will get our target molecule, that is target molecule 248. So friends, this 1,5 dicarbonyl we already studied in my previous lectures. So what we can disconnect over here, because we know that the diethyl malolate is a very good part for the nucleophile or carbanion. So for 1,5 dicarbonyl we are going to add double bond to the next part, so we will get this type of synthones, and you know that alpha beta unsaturated carbon compounds we prepared like this by addition of water molecule. So this is how we are going to get the heterocyclic compound containing nitrogen or any other heteroatoms. So you have as home assignment for this molecule, you need to write down retrosynthesis and synthesis of this molecule. So now let's go for the next molecule. So friends, this is a secondary amine, but don't rush for the FGI of amide. You can see that this molecule nitrogen is beta to this carbonyl, so we can think about the 1,4 Michael addition for this molecule. Okay, so we can think about 1,4 Michael addition of this molecule. So when we disconnect this bond we need to get double bond over here. So reaction of this amine or addition of this amine 1,4 position of Michael addition, we will get our target molecule. So how we can get this molecule? This is now primary amine. So as we have primary amine, let's think about the reduction of CN group to get this molecule. So this part we will get from the reduction of CN, and another part we will get from the alpha beta unsaturated carbonyl compounds. So this is simple. We are going to add water molecule at OH at beta position, and we will get this molecule. So again you have task. Now we get 1, 2, 3, 4, 5. We have 1,5 dicarbonyl compound. We already studied in previous lecture how we can prepare the 1,5 dicarbonyl compound. So your part is write down retrosynthesis and synthesis of this molecule also. Already I covered the retrosynthesis, but up to here you need to go for the simplest starting material, and from that you need to start the synthesis also. So this is also a question for home assignment. Friends, let's go for the next target molecule. So this molecule looks very complex, but you can see that our strategy is helpful for us for the synthesis of this type of molecule. So friends, let's start with this amide formation. So this part is, for the time being, we are considering as AR, and for the 5-membered ring we are going to add the carbonyl group over here. So after disconnection, what we will get? We get NH and COX. Again we are going to add carbonyl over here because this is secondary amine, and again we will get COX and NH2. So what we get? Simple AR CH2 CH2 NH2. So this part is commercially available. Now we get again 1,5,1,4 dicarbonyl compounds, which we already studied in my previous lecture. So friends, this is how we are going to prepare this final compound or retrosynthesize this final compound. Just we have tertiary amine, add carbonyl group and disconnect it. Add carbonyl group, make it amide and disconnect. This is how we are going to prepare the tertiary amines. So friends, this is again a new interesting compound over here. If we have this type of system, that is nitrogen and then double bond next to it, we need to add water molecule to this position. Okay, this alpha position we need to add water molecule. That's why it will become keto and or carbonyl, and then reaction of this nitrogen to this carbonyl will get us our final compound. I will explain with the example. So when we add water molecule to this double bond, especially OH on this carbon next to the nitrogen, we will get this type of molecule. So what actually happens? If we have this type of molecule, this amine lone pair will attack on the carbonyl, and we will get the loss of water molecule, which will lead us to formation of this double bond over here and ring like this. So whenever we have double bond next to the heteroatom, we need to add the OH group next to the nitrogen. Okay, we need to add OH group on the carbon which is next to the nitrogen, that is the carbon which is bearing R group. Okay, so think about this molecule like this. Now this molecule is over here. So what we need to do? We need to go, do addition of water molecule to this double bond, especially OH on the carbon which is next to the nitrogen. Okay, this is how we are going to prepare the molecule. So this is how we are prepared molecule. We have carbonyl group over here, carbonyl group over here, and we have simple methylamine over here. Again we have 1,5 dicarbonyl compound which will give us alpha beta unsaturated ketone and a carbanion containing compound. So this molecule we already prepared by addition of water molecule. So this was our first molecule. Okay, do you remember this? So this molecule we can also prepare by retrosynthesis. So this is how we are going to prepare the different types of heteroatoms containing nitrogen as well as simple primary, secondary and tertiary amines. Again, task for you guys, write down retrosynthesis and synthesis of target molecule 254. This is all about the today's lecture. So this is again homework for you guys. Write down target molecule 258, its retrosynthesis and synthesis. Beside this molecule, we have these three molecules for you guys. So this is a home assignment for you guys. you need to write down the retrosynthesis of and synthesis of target molecule 258, then 263, 240 and 256. Okay, if you have any doubt regarding this type of retrosynthesis, feel free to ask me. Okay, refer these books if you have any doubt, especially Designing Organic Synthesis by Stuart Warren. Thank you.